Let's say that we have an initial square that is divided in 9 smaller squares and that we have eliminated the central one. The same procedure can be done in all these smaller squares, and then the same procedure can be performed in all these even smaller squares, and so on. Let's see how we could construct this pattern. First of all, we should draw the initial square. Let's draw a square. A rectangle, and we could arrange the two sides of this rectangle to be equal. Let's say equal to 10. Now we have this initial square. First of all, we could make a surface that has this square as a boundary, this initial surface. And we may divide this surface into 9 equal smaller squares. For this purpose, we can use the component isotreme. So we will divide this surface, and for the domain, for the division of the domain, we could use the divide domain component. So we will divide the domain of this surface in 3 and 3 into 3 and 3 pieces. So we need the number 3. In order to define the division of U and V of this surface. And now let's preview of the initial one. We have 9 smaller surfaces, 9 equal squares. From this list, we would like to eliminate the central ones. We could use the replace items component. So from this list, we will extract, we will eliminate the item with the index 0, 1, 2, 3, 4, with index 4. So we need another panel with the number 4 here. Let's preview of this. So we have this initial structure. If we put a panel here, we will see that the fourth place of this list is null. In order to eliminate this, we could use the call pattern, not this one. We could use nor this, call null this component. This component gives us here a pattern with false and true. The true is the item that is null, this one. So we could dispatch this list using the component dispatch this list according to this pattern. So here in B we will have this list, the list of the squares, without the null item. Let's preview of this one. So here we have our final list. Now, in order to make the same procedure in all of these squares, we could copy-paste this part of the routine, copy and paste, and plug B into here and there. Let's see what will happen. This is not correct. In order to correct this, we should choose graft, this one, and this one. And we could preview of this one. No, maybe this does not need to be grafted. Now, here we have the new squares. So, we could copy and paste this part of the routine and plug this list here and there, here and there, and preview of this one, and we will have the new pattern. And we could do the same for these smaller squares. If we don't want to have this repetition, we could use the anemone plugin. We could use from here the anemone plugin, the fast loop start and end. We need this and this one. Those two are going to be connected. And we could put the first surface here in D0, so D0 is going to be put here and there, and the final step of this part of the routine must be put here. and we're going to disable all this part of the routine. And preview of this one. And now we need to define the number of iterations with a number slider. Let's say from 0 to 3. And we need to graft this part as we did here and there. We can see that we have the same result using only the anemone, so we don't need this part of the routine. We could delete this part of the routine. And this is the final result.